As part of its goal to bring fresh, exciting designs to the marketplace, the Chrysler Group continues to roll out one new model after another and to equip its models with attractive new features. This month, we're going to cover the latest addition to the new model lineup, the 2005 Dodge Dakota. And we're going to discuss a new feature on Chrysler 300 and Dodge Magnum models, all-wheel drive. Welcome to Master Tech. In this program, we'll first take a look at the general features of the new Dodge Dakota. Then we'll look into, under, and around the new Dakota for the details. After that, we'll discuss the components, operation, and service features of the LX all-wheel drive system. The redesign of the Dodge Dakota has resulted in a new body code and a simplified model lineup for the 2005 model year. ND is the new body designation for the Dakota, which is available with a club cab or a quad cab. There are 3 trim levels for the 2005 model year: ST, SLT, and Laramie. Dakota has become known for providing outstanding interior room in a mid-size pickup, and that continues for 2005. In addition, the ND benefits from new powertrain choices, a new frame and redesigned front suspension, and changes to the safety, HVAC, and body electrical systems, which includes the use of the CAN bus system. That's an overview of how the Dakota has changed. Next, we'll go under hood for some specifics. For 2005, Dakota continues to be available with 3.7-liter V6 and 4.7-liter V8 engines. Both of these engines have seen changes for 2005 that extend across model lines. And these and other changes are the subject of next month's program, Powertrain Update. Later in the model year, Dakota will be available with the high-output version of the 4.7-liter, similar to the engine used previously in Grand Cherokee. This engine was the subject of the July 2001 Master Tech, so be sure to refer to it for background information. Changes to the cooling system include a relocated radiator cap, as well as coolant and windshield washer bottles, which are in a single module. Some of the new electrical system items in the engine compartment have been used on other new models and should look familiar to you by now. The integrated power module combines the power distribution center and front control module. The IOD fuse is located here in the power distribution center. In addition to providing circuit control and protection, the front control module acts as the central gateway for the CAN bus communication system. As on other vehicles, on ND, the CAN B bus is used for body and safety systems, and the CAN C is used for powertrain and anti-lock brakes. CAN C diagnostic allows communication with StarScan, while a LIN bus is used for steering wheel switches. Well, those are some of the main changes you'll find under hood in the new Dakota. Next, we're going under the ND for a look at what's new there. The fuel system on the new Dakota has been designed to meet LEV 2 evaporative emission standards. All applications use an onboard refueling vapor recovery system to limit emissions during refueling, and a natural vacuum leak detection system to ensure the integrity of the evaporative emissions system. One of the changes to transmissions in the new Dakota occurs later this year. That's when a new Getrag 6-speed manual transmission will be introduced behind 3.7-liter and 4.7-liter engines. One way of identifying the new manual transmission is the companion flange at the rear. As for the automatics, the 42 RLE is available with 3.7-liter engines, and the 545 RFE is available with 4.7-liter engines and standard with the 4.7-liter HO. The transmission control system has undergone some changes seen previously in other applications. The most noticeable is the use of a tow haul switch on the end of the shift lever, similar to the one used on Ram truck and Durango. Just as in those applications, the tow haul mode adjusts shift schedules to accommodate heavier loads, while still allowing modified overdrive under certain conditions. The new Dakota continues to offer a part-time four-wheel drive system using the NV233 transfer case and a full-time system using the NV244. One big difference on the ND is that the front control module now controls shifting. Axles remain basically the same on the new Dakota. However, note that in addition to the 392 and 355 ratios, a new ratio 321 will be offered. The frame under the 2005 Dakota is an all-new design, and the use of box sections along the entire length provides exceptional stiffness. Note that with the new frame, damaged rail tips can be cut off and new ones welded on. There are two skid plates under the ND, one for the engine, transmission, and transfer case, and the other for the fuel tank. Both four-wheel drive and two-wheel drive ND applications benefit from a new short long-arm front suspension. The coil spring-over shock absorber configuration allows greater flexibility in tuning for ride and handling. In the area of service, note the camber and caster is now adjusted at the lower control arm using cam bolts. The new Dakota continues to use rear leaf springs, and now a stabilizer bar is standard equipment. At the front of the new Dakota, you'll notice a new dual piston caliper, which it shares with Dodge Durango and Ram truck. A drum-type rear brake is now used in all applications. Four-wheel anti-lock brakes continue to be available on Dakota. One change to this system is that now it uses active wheel speed sensors. That does it for features under the ND. Next, we'll take a look at the exterior of the new Dakota. Besides the bold new styling, one of the more obvious body changes is here at the side of club cab models. These models now have rear access doors with hinges at the rear and latches at the top and bottom. Changes to the Dakota's headlamp units are similar to those made to the 2004 Durango, and service is similar as well. One big change for 2005 is the addition of automatic headlamps as standard equipment on Laramie models. The auto headlamp function is controlled by the cabin compartment node, a control module which is part of the cluster. A sensor on the instrument panel top cover provides the system with ambient light information. On Dakotas equipped with remote keyless entry, one change you're sure to notice involves the RKE transmitter. The transmitter is now integrated into the keyhead. The Sentry Key transmitter is also part of the keyhead on vehicles equipped with this feature. Door locking and unlocking functions are controlled by the cabin compartment node described earlier. In fact, the CCN is responsible for providing and coordinating a number of body electrical features. That does it for some of the more notable exterior features. Next, we're going to take a look inside the new Dakota. Let's begin our look inside the ND with some new features of the restraint systems. The first is a direct result of the addition of rear doors to club cab models. Because there's no B-pillar, the turning loop adjusters for the front seat belts are now mounted on the roof, and the retractors are mounted on the floor. The new Dakota uses multi-stage driver and front passenger airbags along with the Occupant Classification System, or OCS. The OCS on Dakota uses strain gauge sensors at the corners of the front passenger seat, along with a seat track position sensor. There's also a seat track position sensor on the driver's seat. The Occupant Classification module under the front passenger seat receives sensor inputs and communicates with the Occupant Restraint Controller, which is located under the center console. For more information about the Occupant Classification System, be sure to see the December 2003 Master Tech. Besides deploying the driver and front passenger airbags and operating the Occupant Classification System, the Occupant Restraint Controller is also responsible for deploying the available side curtain airbags. Impact sensors for the side curtain airbags are mounted on the floor under the front seats. And speaking of seats, the 2005 Dakota is available with leather or cloth heated front seats. They're similar to the ones we looked at on the 2004 Durango, which was the subject of the October 2003 MasterTech. A new single-zone manual-controlled HVAC system with air conditioning is standard on all ND models. Many of the system components are accessible without rolling back the instrument panel. These include the blower motor and resistor, blower cage, evap temp sensor, and panel and defroster actuators. Well, those are some of the more notable features on the new Dakota. Next up, LX all-wheel drive. Let's start off our look at the all-wheel drive system with its availability. The system is available on Dodge Magnum SXT and RT, and Chrysler 300 Touring and 300C. It's also available on international Chrysler 300C models. In all cases, the system is used with a 3.5 or 5.7-liter engine coupled to a NAG-1 transmission. NAG-1 transmission housings on models with all-wheel drive accommodate a bolt-on transfer case that distributes torque to the front and rear axles. The MS-140 transfer case uses a center differential to send approximately 62% of torque to the rear axle and 38% to the front at all times. Under Schedule A, the transfer case is maintenance-free, and the fluid should not need to be changed or topped off. Under Schedule B, severe service, there is a 48,000-mile fluid change interval. Be sure to use only Mopar transfer case lubricant LX when adding or changing fluid. The all-wheel drive system uses a front drive shaft with two U-joints to send torque to the front differential. The differential, which attaches to the oil pan, uses 75W90 Mopar gear and axle lube. On one side of the front differential is an intermediate shaft which extends through a tube in the oil pan to a support bearing. The intermediate shaft allows the use of equal-length half shafts, which reduces torque steer. The rear part of the all-wheel drive system drivetrain is similar to that used in rear-wheel drive applications. The drive shaft is shorter to accommodate the transfer case. It delivers torque to a rear axle that's similar to the one used on rear-wheel drive applications. The rear differential uses 75W140 Mopar synthetic gear lube, and it also has a 48,000-mile fluid change interval under Schedule B. In addition to the drivetrain, LX all-wheel drive models have a number of other differences from their rear-wheel drive counterparts. For starters, all-wheel drive models use a different transmission crossmember and different engine mounts. The steering gear is mounted in a different location, and the tie rod ends are offset to provide clearance for the wheels during turning. 18-inch aluminum wheels are standard with all-wheel drive, and these wheels have a different offset than those used on rear-wheel drive models. In the area of brakes, note that the twin-piston calipers used on the front of all-wheel drive models are mounted over the forward surface of the rotors. Also note that the front tone wheels used for ABS and ESP functions are on the half shafts instead of on the front bearings. The components which make up the short long-arm front suspension on all-wheel drive models are different from those used on rear-wheel drive models. One of the most noticeable differences is the use of a single-piece lower control arm with a single ball joint connection at the steering knuckle. You're also going to find some differences when it comes to servicing the front suspension. For one thing, all-wheel drive models ride an inch higher as measured from the front rail to the ground. A smaller caster angle on all-wheel drive models is another difference. Camber and caster adjustments is similar to that on rear-wheel drive models, namely moving the cradle to make the adjustments first, followed by the use of notched bolts at the lower control arm inboard pivot points. However, note that the adjustment bolts are different from those used in rear-wheel drive applications. Our final difference concerns the rear suspension on all-wheel drive models. It's similar to the suspension used with rear-wheel drive. However, note the use of spacers on the rear to accommodate for the 1-inch difference in ride height. Well, that does it for this MasterTech program. Join us next month when we'll be discussing recent changes to powertrains. Thanks for watching.